The 1920s to 1940s marked a pivotal era in computing history, the era of giant computers. These machines were nothing like the sleek laptops or smartphones we know today. Instead, they were colossal structures, often occupying entire rooms or even buildings. These early computers, with their complex wiring and bulky components, laid the foundation for the digital revolution that would shape the world. This period witnessed groundbreaking advancements in technology, driven by the increasing need for faster and more efficient calculations. The world was becoming increasingly complex, with scientists and engineers tackling intricate problems in fields like physics, engineering, and cryptography. These early computers emerged as powerful tools to address these challenges. Imagine, if you will, walking into a vast room filled with towering metal cabinets, interconnected by a maze of wires and vacuum tubes. The air hums with a constant electrical buzz, and the smell of ozone hangs heavy in the air. This was the reality of early computers. These machines were behemoths, often weighing several tons and consuming enormous amounts of power. Their physical size was a direct consequence of the technology available at the time. Vacuum tubes used for electronic switching were bulky and unreliable, requiring thousands to perform even basic calculations. Punch cards and paper tape were the primary input methods, with results often printed on massive line printers. These early computers were far from user-friendly, requiring specialized knowledge and teams of engineers to operate and maintain. The development of these giant computers was driven by necessity. World War II, in particular, created an urgent demand for computational power. Governments and militaries needed machines capable of breaking enemy codes, calculating artillery trajectories, and designing new weapons. One of the most pressing problems these early computers tackled was code breaking. The Enigma machine, used by the Germans to encrypt their military communications, posed a significant challenge to Allied forces. Colossus, a secret British computer, was built specifically to crack the Enigma code, playing a crucial role in the Allied victory. Beyond wartime applications, these machines also found use in scientific research and engineering. They helped scientists perform complex calculations, simulate physical phenomena, and analyze large data sets. The development of the atomic bomb, for instance, relied heavily on the computational power of early computers. The ENIAC, or Electronic Numerical Integrator and Computer, completed in 1945, stands as a prime example of these early giants. Developed at the University of Pennsylvania, it was the first general-purpose electronic digital computer. ENIAC, with its 18,000 vacuum tubes and massive size, could perform complex calculations at an unprecedented speed. Another groundbreaking machine was Colossus, developed in secret by British code breakers during World War II. Colossus used thousands of vacuum tubes to decipher German messages encrypted by the Lorenz cipher machine. Its impact on the war effort was significant, though its existence remained a closely guarded secret for decades. These machines, though primitive by today's standards, represented significant leaps in computing technology. They demonstrated the potential of electronic computation and paved the way for the development of smaller, faster, and more accessible computers. The giant computers of the 1920s through the 1940s might seem like relics of a bygone era, but their impact on modern technology is undeniable. They laid the groundwork for the digital revolution, leading to the development of the microchip, the personal computer, and the internet. The lessons learned from building and operating these early machines were invaluable. They spurred further innovation in hardware, software, and computer architecture. The concept of stored programs pioneered by machines like the EDVAC, or Electronic Discrete Variable Automatic Computer, revolutionized computing, making computers more versatile and easier to program. These early computers, despite their limitations, ignited the imagination of scientists, engineers, and mathematicians. They demonstrated the transformative power of computation, inspiring future generations to push the boundaries of what was possible. The legacy of these giants lives on in every smartphone, laptop, and supercomputer that shapes our world today.